In this video, I'm going to show you a way that students could actually prove that pi is 3.14. There are a lot of videos on the internet that do this same technique, but in this one, I use manipulatives that the students can actually use. So if we start with a circle that's 360 degrees and divide that by 2, we get 180 degrees. So let's go ahead and divide our circle into 2. Now we have 180 degrees. At this point, you could divide your half circle into 2, but I chose 3 so that I could move along towards my proof. So 180 degrees divided by 3 is 60. Here you can see 60 degrees rearranged. Now let's take a look at dividing our half circle into 6 parts. This will give us 30 degrees. At this point, you can really start to see what shape our half circle is going to turn into. Let's divide our half circle by 12 now and see what 15 degrees will look like. So here's 15 degrees rearranged to almost look like a rectangle now. And the area of a rectangle is going to be length times width. Our length ended up being about 5.2, and our width is 3, which gives us 15.6 square inches. If we go back and look at our original circle, we see that it had a radius of 3.125. This would give us a total of 30.68 square inches. Our formula for a half circle is going to be area equals 1/2 pi r squared. So if we just plug in what we already figured out into this formula, we come up with 15.34 square inches. I'll be honest here, guys, I was a little bit disappointed that I came up with a larger number than what the formula said I should. But this is exactly what students need to do. They need to research and understand, okay, so how did that work? I mean, this is what helps students learn. All in all, this is a wonderful experiment and I enjoyed it. The manipulatives are awesome. Students, I think, it's hands-on, so they would really enjoy that. Just to kind of recap, we divided 180 by 12 and came up with 15 degrees, and we were trying to prove that we could turn a half circle into a rectangle and use length times width instead of pi r squared to prove the area of a circle. If you know why I came up with a larger number than the formula, please let me know in the comments below.